James Webb Space Telescope has confirmed the existence of an Earth-sized planet. The planet is named LHS 475b. It's a rocky world that orbits a red dwarf star roughly 41 light-years away in the constellation of Octans. When astronomers discovered this planet, they thought it was an ordinary world orbiting a red dwarf star. However, a detailed analysis of this planet's atmosphere has puzzled astronomers. They had never seen a planet with such a unique atmospheric spectrum. So how did Webb make this important discovery? What's so special about the Earth-sized planet confirmed by the telescope? Finally, and most importantly, what else did Webb reveal about this distant exoplanet? The planet's existence was first hinted at by NASA's Transiting Exoplanet Survey Satellite, or TESS. Over the years, the primary mission of TESS has been to survey the bright stars near Earth and look for transiting planets around them. The satellite has surveyed 85% of the sky with its wide-field cameras. TESS has discovered planets ranging from small rocky worlds to gas giants. However, besides finding new planets, one of the satellite's goals was to look for prime targets for further confirmation and characterization by the James Webb Space Telescope. One such potential target was LHS 475b. So astronomers decide to probe it in detail using the Webb telescope. When an exoplanet transits its star as seen from Earth, we observe a dip in starlight. By analyzing these fluctuations in the light curve of the star, the presence of a planet can be inferred. This is known as the transit method. It's one of the most straightforward methods to detect exoplanets. The majority of exoplanets confirmed so far have been discovered using the transit method, and this is how TESS speculated the existence of LHS 475b. Even Webb used the same approach to confirm the planet's existence. Webb observed two transits of the exoplanet using its near-spec G395H grating. It covers a wavelength range of 2.87 to 5.14 microns. Each transit lasts 4.4 hours, providing Webb an exposure time of 2.9 hours. Later, the transit's data were extracted and analyzed independently with different pipelines such as Eureka, Firefly, and Tiberius. The star's light curve revealed that the planet completes an orbit around it in just a couple of days. Since it's a very short orbital period, it means that LHS 475b lies closer to its star than any planet in the solar system. For reference, Mercury, the closest planet to the Sun, completes an orbit in 88 days. However, LHS 475, the host star in this case, is an M3.5 main sequence dwarf star. The surface temperature of such stars is around half that of the Sun. So LHS 475 is an M-type star having a surface temperature of about 3300 Kelvin. Further, the planet is tidally locked with its host star. This means only one side of the planet faces its star, basked in permanent daylight. Things got puzzling when astronomers tried to study its atmosphere. At present, Webb is the only telescope capable of characterizing the atmospheres of Earth-sized exoplanets. And this is where Webb's observations become even more interesting. To analyze the atmosphere of LHS 475b, Webb studied its transmission spectrum. But what's that? We mentioned that when a planet transits its host star, there occurs a dimming in starlight. But that's not the only significant thing that happens during transit. As the planet transits its parent star, the starlight gets modified as it filters through its atmosphere. So indirectly, the transmitted light contains information regarding the composition of the planetary atmosphere. Astronomers then compare this filtered starlight to the natural starlight to to study the exoplanet's atmosphere. The researchers studied the transmission spectrum of LHS 475b. Although they have yet to conclude what's in the atmosphere, they have confirmed what's not there. This is the exoplanet's transmission spectrum, and a flat curve like this can be pretty interesting. Different colored lines represent different atmospheric models. The purple line corresponds to a carbon dioxide-rich atmosphere. The green line denotes a methane-rich atmosphere, and a yellow line is a featureless spectrum signifying no atmosphere at all. A pure methane atmosphere represented by the green line is not favored. That's because if methane were present, we would have seen a sharp dip in the spectrum at 3.3 microns, as the molecule would have absorbed more starlight there. The data were found to be best consistent with a featureless spectrum, hinting the planet may not have any atmosphere at all. But there's a twist. An atmosphere composed of 100% carbon dioxide is so compact that it becomes very challenging to detect it. This means there's a possibility that the atmosphere of LHS 475b is pure carbon dioxide. So more precise measurements are required to distinguish a pure carbon dioxide atmosphere from no atmosphere at all. In addition to this crucial information about the atmospheric composition, Webb has also revealed that the planet is a few hundred degrees warmer than Earth. Hence, if clouds are detected on the planet, the researchers may conclude that the planet is more like Venus, which has a carbon dioxide atmosphere and is perpetually shrouded in thick clouds. Webb is scheduled to obtain additional spectra of this planet with upcoming observations this summer. These primary observations of an Earth-sized rocky planet will pave the way for studying similar exoplanets in the future. The discovery of the first exoplanet was confirmed in 1992, and in the past 3 decades, NASA has confirmed the existence of more than 5,000 of them. Some of these planets may have conditions that can host organic life as we know it. With the James Webb Space Telescope, we have a perfect tool to explore those planets in detail and take the research on planetary science and astrobiology to the next level. Besides exoplanets, Webb has made significant discoveries in other fields of astronomy as well. We have published a detailed video on Webb's top discoveries so far, from the solar system to stellar astrophysics, and from exoplanets to extragalactic astronomy. So, if you missed any major Webb discovery, make sure to watch this episode of the Sunday Discovery series.